According to the transformer manufacturer's instructions, the load to be considered is the maximum potential and permissible load, which is 80% of the transformer's maximum output rating. This is because the transformer must be able to handle the potential increase in load if higher wattage lamps are installed in the future. With the current installed load of 13 watts per puck light, the load on each transformer is around 78%. This is within the 80% allowance specified by the manufacturer. Therefore, the current installation is acceptable. However, if 15-watt lamps are installed, the load on each transformer would increase to around 90%. This would exceed the 80% allowance and violate the manufacturer's instructions. To ensure compliance with the manufacturer's instructions and prevent potential safety hazards, you should recommend that the transformers be reinstalled vertically. This will eliminate the possibility of exceeding the allowable load and overheating the transformers. Article 220.14d is a similar concept in that it requires branch circuits to be protected against overcurrent based on the maximum potential load, not just the current load. This is to ensure that the circuit can handle the potential future increase in load. In this case, it is prudent to consider the maximum potential load, which is with 15-watt lamps installed. Since the current installation exceeds the manufacturer's allowable load under this condition, the transformer should be reinstalled vertically to ensure safety and compliance with the manufacturer's instructions. When dealing with electrical installations, it's crucial to adhere to manufacturer specifications and relevant electrical codes. In this specific scenario, the question revolves around determining the appropriate load to consider for transformers powering low voltage puck lights. The transformers are marked with a caution stating that they are heat-sensitive devices and must be installed vertically with the arrows pointing up. However, the manufacturer's literature also provides an exception, allowing horizontal installation if the ambient temperature is below 120 degrees Fahrenheit and the load does not exceed 80% of the maximum output rating. The puck lights are rated for a maximum of 15 watts each, but the currently installed lamps are believed to be 13 watts. The electrician argues that the current load is within the allowable limit, while the concern is that someone could install 15-watt lamps in the future, exceeding the transformer's capacity when horizontally mounted. To determine the appropriate course of action, it is necessary to examine the manufacturer's instructions carefully. The manufacturer explicitly states that the transformers must be installed vertically to avoid heat entrapment. The exception for horizontal mounting is conditional, requiring adherence to temperature and load limitations. Given the potential for future installation of higher wattage lamps, the maximum potential load must be considered. If the potential load exceeds the 80% threshold, the transformers must be installed vertically, regardless of the current load. In this case, with 16 puck lights per transformer, the total load with 13-watt lamps is 208 watts. With 15-watt lamps, the total load is 240 watts. For a 300-watt transformer, the 80% limit is 240 watts. Therefore, the maximum potential load with 15-watt lamps is exactly at the limit, but it's best to be safer and the manufacturer suggests vertical install to avoid overheating. Since there's no guarantee that future installations will use only 13-watt lamps, it's prudent to assume the potential for 15-watt lamps. This assumption aligns with the principle of considering the maximum potential load, as outlined in Article 220.14d of the National Electrical Code, or NEC. While Article 220.14d specifically addresses branch circuit overcurrent protection, the underlying concept is applicable here. It requires branch circuits to be protected based on the maximum potential load, not just the current load, to ensure the circuit can handle future increases in demand. In this scenario, if the transformers are installed horizontally and 15-watt lamps are subsequently installed, the load would reach the maximum allowable limit, potentially leading to overheating and premature failure of the transformers. Therefore, to ensure safety and compliance with the manufacturer's instructions, it's recommended to install the transformers vertically. This eliminates the risk of exceeding the allowable load and overheating the transformers, regardless of the wattage of the lamps currently installed or potentially installed in the future. Furthermore, it's crucial to document the decision-making process and rationale behind the installation. This documentation should include the manufacturer's instructions, relevant electrical codes, and the reasoning for choosing the vertical installation method. This documentation serves as evidence of due diligence and compliance with safety standards. In addition to the technical considerations, it's also important to address the electrician's perspective. While the electrician may believe that the current installation is acceptable, it's essential to explain the potential risks associated with horizontal mounting and the importance of considering the maximum potential load. This explanation should be based on the manufacturer's instructions, relevant electrical codes, and the principles of electrical safety. By engaging in open communication and providing clear explanations, it's possible to reach a consensus and ensure that the installation is performed in a safe and compliant manner. Moreover, it's recommended to conduct regular inspections of the installation to verify that the transformers are operating within their specified limits. These inspections should include checking the ambient temperature around the transformers, measuring the load on each transformer, and verifying that the lamps installed are within the allowable wattage range. Any deviations from the specified limit should be addressed promptly to prevent potential safety hazards. In summary, when determining the appropriate load to consider for transformers powering low voltage PAC lights, the maximum potential load should be taken into account. If the potential load exceeds the manufacturer's allowable limit for horizontal mounting, the transformer should be installed vertically to ensure safety and compliance with the manufacturer's instructions. This approach aligns with the principle of considering the maximum potential load, as outlined in Article 220.14d of the NEC, and ensures that the electrical system can handle future increases in demand without posing a safety risk. Remember that electrical installations must prioritize safety and compliance with industry standards. Consulting with qualified electrical professionals and adhering to manufacturers' instructions is essential for ensuring a safe and reliable electrical system. The National Electrical Code, or NEC, serves as a comprehensive guideline for safe electrical installations. It's crucial to be familiar with the relevant sections of the NEC and to apply them appropriately to each specific situation. The NEC is updated regularly to reflect advancements in technology and changes in industry practices. Therefore, it's important to stay informed about the latest version of the NEC and to ensure that all electrical installations comply with its requirements. In addition to the NEC, local electrical codes and regulations may also apply. These local codes may impose additional requirements or restrictions beyond those specified in the NEC. It's essential to be aware of these local codes and regulations and to ensure that all electrical installations comply with them. When in doubt, it's always best to consult with the qualified electrical inspector or engineer to ensure that the installation meets all applicable requirements. Electrical safety is paramount, and any potential risks should be addressed promptly and effectively. Ignoring safety concerns or cutting corners can have serious consequences, including electrical shocks, fires, and even fatalities. Therefore, it's crucial to prioritize safety in all electrical installations and to take all necessary precautions to prevent accidents. Regular maintenance and inspections are also essential for ensuring the continued safety and reliability of electrical systems. These inspections should be performed by qualified electrical professionals and should include a thorough examination of all electrical components and connections. Any damaged or worn component should be replaced promptly, and any potential hazard should be addressed immediately. Electrical systems are complex and require specialized knowledge and skills to install, maintain, and repair. It's never advisable to attempt electrical work without proper training and experience. Working with electricity can be dangerous, and even minor mistakes can have serious consequences. Therefore, it's always best to leave electrical work to qualified professionals who have the necessary expertise to perform the job safely and effectively. In conclusion, when dealing with electrical installations, safety and compliance should always be the top priorities. Adhering to manufacturers' instructions, complying with relevant electrical codes, and consulting with qualified professionals are essential for ensuring a safe and reliable electrical system. Never take shortcuts or compromise on safety, as the potential consequences can be severe. By prioritizing safety and following best practices, it's possible to create electrical systems that are both safe and efficient.